Okay, so we can take the derivative of a bunch of stuff now, but now we need to take a look at what happens if we have a composition of functions. So one function is inside of another function. So what we do is we take the derivative with respect to u of the outside function. Then we take the derivative of the inside function. Another way to look at this is like in the blue. So I have the outside function is f, the inside function is g. So we're going to take the derivative of the outside function, leave the inside, then take the derivative of the inside function. I need to rewrite that. I need to readjust and rewrite. Okay, so we're going to practice this. So the inside of y is equal to x squared plus 1 raised to the third power would be this x squared plus 1. That's the inside. So I'm just going to say the inside over here is x squared plus 1. The outside is all of that is being raised to the third power. So it's like u to the third power, kind of. So I like to put the inside and the outside in different rectangles, and then I start from the outside and work in. So first, I'm going to start with the outside. I need to take the derivative, take care of this third power. So I'm going to have dy dx is equal to, the inside stays the same. So the third power needs to come to the front. And then I'm going to raise this to the second power. Remember, this is like this is basically our u that we've defined. So now that we have taken the outside derivative, I'm going to take the derivative of the inside. So I've taken the derivative of the outside, now the derivative of the inside, times 2x. The derivative of x squared plus 1 is 2x. So just simplify. Dy dx is equal to 6x times x squared plus 1 raised to the second power. All right, let's work on the next one. Roots are just chain rules, they're powers disguised. So I'm going to do x squared minus 1 raised to the 1/2 power. And what is the inside u part of our function? That is this x squared minus 1. So I'm going to have my outside function and my inside function. So we start with the outside. F prime of x is equal to, the 1/2 comes in front. Leave the inside, it's basically u, minus 1, raised to the negative 1/2 times the derivative of the inside part. So 2x minus 1, the derivative is 2x. Simplify. I see the 2's cancel, the 2 and the 1/2 cancels. I get x over, I'm going to take care of my negative 1/2 here, is x squared minus 1 to the 1/2, or x over x squared minus 1, the square root of x squared minus x squared minus 1. Okay, either is good. Let's go ahead and tackle the next one. So what's going on here? Well, I'm not super, I can see in the bottom that inside of the squared is this 2t minus 3. So I'm going to change this so I don't have to do quotient rule to have my denominator in the numerator. So negative 7 times 2t minus 3 raised to the negative 2. And since we're only multiplying by a scalar, I do not have to use the product rule. I can just use in this case, the chain rule. Okay. So inside part is 2t minus 3. So we're going to take care of, oh, wait, I didn't do my rectangles. Okay. The outside part is all of this. So the negative 2, power of negative 2 is being applied to the 2t minus 3. So the inside part is 2t minus 3. We start with the outside. So g prime of t is equal to, multiply, giving me 14. The inside stays the same, 2t minus 3 raised to the negative third power times the derivative of the inside, which is 2. Simplify, and it's a g. 28 over 2t minus 3 raised to the third power. This does not surprise me that the third power and the second power, or the second power becomes a third power in the denominator because the powers decreased by 1, right? Number 4. What to do here? This is, okay, let's go ahead and use the chain rule, and then we'll do it 2 ways, actually. So I'm going to use the chain rule. I'm going to take my denominator and move it to the top, giving me 3x squared plus 4 raised to the negative 1. And the inside function is going to be inside, what's inside the parentheses, 3x squared plus 4. That's basically my u. And then the outside is the negative 1. So I have the negative 1 is the outside. The inside is 3x squared plus 4. Next, we're going to go ahead and take the derivative of the outside. So move the 1 to the front. So negative 1 times the inside stays the same, 3x squared plus 4. And then take the derivative. So we're going to chain on the derivative of the inside. 3x squared plus 4, the derivative would be 6x. Simplify. Negative 6x over, you know what I forgot is when I did the derivative of the outside, I forgot to decrease my negative 1 to negative 2. Yeah, don't forget that. So the bottom is 3x squared plus 4 raised to the second power in the denominator. All right, so that's one way. This was using the chain rule. And now we're going to do the same thing, but we're going to use, well, we're not going to do the same thing. We're going to solve the same problem. F of x is equal to 1 over 3x squared plus 4. And we're going to use the quotient rule because we know how to do that. So low d high, high d low over low squared. Okay, so we're going to get low f prime of x is equal to 3x squared plus 4. The derivative of 1 is 0, so d high, minus the low d high, high d low. The derivative of the denominator here is 6x. Should say that with more confidence. All over 3x squared plus 4 squared. I can see our first term cancels. The second term is negative 6. So we get f prime of x is equal to negative 6x over 3x squared plus 4 squared. And notice, matchy, matchy. So 2 different strategies to get the same result in the end. Remember, there's lots of different ways to do the same thing. Okay, so now we're really, the trig functions are where we end up with a lot of chain rule, because if we don't have just a plain x in our function, like if we have cosine of 3x or cosine of x squared, then the inside is not just a plain x, it's like a function, right? A different function that we're going to have to apply the chain rule for. Let's do some examples. So cosine of x squared. Remember, this is just a sneaky way to write cosine of x all squared. And the outside function is going to be u squared. The inside function is cosine x. So we start, y prime is equal to, bring down the 2 times the cosine of x, that's the inside, raised to the 2 minus 1 gives me 1, times the derivative of the inside times negative sine of x. So y prime is equal to negative 2 cosine x times sine x. Whoop-de-whoop. All right, number 6. This time, where is our inside function? The inside is the 3x squared, because we're going to have to first apply, because it on the outside is cosine x. So we're starting with what we would evaluate first, which was 3x squared, and then we would apply the cosine x squared. Okay, so we're going to do y prime is equal to the derivative of cosine is negative sine of, we keep the inside, 3x squared times the derivative, I like it when I highlight, okay? The derivative of the inside is 6x. So we get y prime is equal to negative 6x sine of 3x squared. 7. We have 2 more. All right, inside, outside, what's going on here? All right, I have, whoa, there's a lot going on here. There's actually more than one rule we have to apply. We have product rule here. We have 5x squared times the secant of 3x. Since the 5x squared is not a constant, we can't just tack it on to our other function. So we have to apply product rule. But then I also see right here the secant 3x is a chain rule situation. So we have 2 rules that we got to tackle. We're going to start with the product rule. So left d right, right d left. So left would be 5x squared, d right, left d right, plus right d left. Okay. So left d right. Okay, the right is right here. So chain rule, the outside function, oh, I don't have enough colors. The outside function is secant of u. The inside function is 3x. So the derivative of secant is secant tangent. So secant of 3x times the tangent of 3x, and then tack on the derivative of the inside, which is 3. Plus, we're going to have to do the right, which is secant of 3x times d left 10x. Y prime is equal to, we got to simplify a little bit, giving us 15x squared. 15x squared. Secant 3x times the tangent of 3x plus 10x secant 3x. Whew, we survived. Okay, number 8. This one, what's going on? We actually have 3 situations happening here. A chain within a chain. So we're going to start with the outside, which is all of this. The secant of 2x plus 3. This actually, I remember, does not equal cosecant, all these letters, cosecant to the 4th of 2x plus 3. The 4 is actually being applied to the parentheses, okay? So what we're going to do is the 4 is only being applied to the parentheses, so the outsidemost layer is the secant of all of this. Then the next layer would be applying the 4th to the inside, which is 2x plus 3. Okay, so we're going to start with the outside. Y prime is equal to the cosecant bring the 4 down. No, just kidding. We need to take, what is the derivative of cosecant? What is the derivative of cosecant? The derivative is negative cosecant x tangent x. So negative cosecant of the inside, which is 2x plus 3 to the 4th power, times cotangent of the inside, 2x plus 3 raised to the 4th power. So we took care of the outsidemost box. What about the next rectangle? Well, if I cover it up, well, I tried to cover it up on my iPad just now, but I realized you can't see that. So ignore the cosecant. How do we take the derivative of 2x plus 3 raised to the 4th power? So bring the 4 down. The inside 2x plus 3 stays the same, and the power on the parentheses reduces to a 3. Then lastly, the derivative of the inside, 2x plus 3, is 2. Now we can simplify, giving us 2 times 4 times negative 1 is negative 8 cosecant of 2x plus 3 raised to the 4th times cotangent of 2x plus 3 raised to the 4th times 2x plus 3 raised to the 3rd. I'm not going to say that this one is nice and tidy, but it's what it is. So this is the derivative using the chain rule 3 times.